All right. And then what I'll do is I'll kind of introduce everybody. So, thank you so much for everybody joining another one of our sessions. This one, as you know, is also on or is about processing large-scale data with Elasticsearch engine. Today we've got Jagadish Vemugunta. Jagadish and I go way back, I think to 2006, maybe, give or take, when I was very, very fortunate to convincing you to come to Jacksonville. I think you were coming out of New Jersey, if I remember correctly. So we've had a very, very long-standing relationship. So I'm very excited to have him here today. Jagadish is a high-level director at one of the largest healthcare organizations in the country. And he is very, very instrumental in kind of pioneering Elastic over at this organization. So what I'm going to do is I'm going to move my host credentials over to you, Jagadish. So just again, keep an eye on the tab on the participants, just to make sure that you allow them in once they get into the waiting room, because there are some people that have still RSVP'd that are not on just yet. And then also near the end, we can do a little Q&A, and I encourage everybody to post questions on the chat, and then me and Jagadish will be able to answer some of those questions for you. All right, so Jagadish, you'll see an update here where you are now the host.
Hey, thank you, Pete, and everyone on this call. My name is Jagdish. I work for a large enterprise with the healthcare. My primary focus is on the Elasticsearch engine. Let me give you a little bit background about myself. I'm a seasoned technician. I grew all the way from a developer to a senior developer to a team lead to an architect to a principal architect and leading a large enterprise architecture team, followed by a director playing a role of innovation and service strategy for a large healthcare industry. I may not be able to disclose the name because of the confidentiality of it. I was asked not to disclose the name of the company by our lawyers. I'm sorry about it. I think to talk about Elasticsearch, my interest grew last year in Elasticsearch because it's solving large problems that has enterprise search needs. When I talk about search needs is you talk about relational databases in general. You always generally do a predicate-based searches, but if you want to do searches on complex search patterns, so I think Elasticsearch is a great platform. I think there is a lot of debate on a public platform between Elasticsearch and Solar. That's also another open source implementation. I'll brief about it, what the differences are, why the industry is getting attracted to Elastic than the open source implementation of Solar. To me, I'm the certified Elasticsearch engineer myself. There are very few people in the country who got certified. Generally, it takes 1.5 years to get certified on this engine because it's what they do is it's a 3-hour exam. They throw you 10 to 12 problems, real world problems. Sometimes they will ask you to build a large cluster. They will ask you to write a use case. Given a use case, how do you write a most effective query? They will ask you to enable security. What they want to test is they want to test your engineering abilities, whether you can play a role of a good architect. Anyone can learn Elasticsearch with a laptop in their hand, but managing large-scale Elasticsearch clusters or a group of clusters is going to be quite challenging because there is a data piece of it, the storage piece of it, there is the compute piece of it, there are configuration files, and there are many knobs that can be tweaked here and there to get the performance out of the engine. And so there are so many integration options available. So we'll talk about some of them in this. So I'm a qualified engineer to talk about this, been certified I think last month. I think I haven't received my badge yet. I did because it was quite challenging as a competitive exam for a long time. After I did my engineering, I haven't seen an exam that is as competitive as Elasticsearch. It's very well organized exam. If you want to pursue your career in Elasticsearch, I think I strongly recommend you prepare for it and you get certified on that exam. You can learn a lot about infrastructure, administration, and architecture, and also how search engines are built on a modern landscape. With that said, as Pete mentioned, please post your questions in the chat window. We'll take those questions and we'll answer accordingly. I think I don't know what is the right format to present, but I have prepared a deck. But this is take this as an interactive session, and ask questions. I should be able to answer most of them because we build a large scale implementation right now in production. So, hold on.
Yeah, Jagadish, you should be able to share your screen.
Yeah, I'm sharing it. Can you all see my screen? Are you able to see my screen?
Yeah, Jagadish, we can see it. There are people in the chat saying they can see it.
Okay. Yeah, that's great. Okay, let me do this. Okay. So
hey, Jagadish, right before you get started, just check the participants if there's anyone in the rating room.
Should I accept that? What should I do?
Yeah, just admit the people in the waiting room if there are people there. If they're not, then I just wanted to make sure before you start starting going into it.
Okay, I'm double checking to make sure that. Okay, participants, I'm there. I can see. I don't see any of them on waiting.
Okay, that's awesome. Just wanted to make sure.
Okay.
Okay. Yep, go ahead.
So, okay. If you look at why Elastic has become very popular compared to other open source search engines. When you look at an enterprise, a search engine on its own will not do any good. The biggest thing that an organization can be very effective with any search engine is should have a strong integration platform so that the data feed can be ingested into the platform at ease. And the user interface that comes with the engine that can be queryable, that can be viewable for all your search data. I think a strong integration along with the search engine with the good user interface will make a platform very appealing. Just having a search engine on its own may not be as effective because you need to write all those integrations yourself. That has made Elasticsearch as a most appealing platform than other competitive search engines. So you have Beats and Logstash. Beats are nothing but a lightweight file shippers and agents that are sitting on your client machines that ships the data directly into Elastic. Search, or it can ship into Logstash. Logstash is the ELT platform, I would say, is where you get the data from different sources, whether it's a database, whether it's a file system, or it's a Kafka topic. There are about more than 100 integrations available from Logstash. You get the data from different backend systems. Then you can transform, enrich, denormalize the data using using Logstack specific syntax and ingest into Elasticsearch. So this is like a lightweight ELT engine that is being used heavily by many organizations for Logstash, using Logstash. Also, Logstash can handle back pressure very effectively. That means assume that you have a read or a write throughput into Elasticsearch. Your Elasticsearch cluster has some problems and it is not able to cope up with the speed that the way at the rate the client is writing the data into. What Logstash can do as a buffer, it can handle the back pressure and it can persist the data locally into this temporary queues or persistent queues inside Logstash. Once the Elasticsearch engine recovers from the bad state to a good state, it can re-ingest the data so that the client applications are not impacted because they're just using Logstash as their ingestion platform. Generally, what organizations on large scale we do at Florida in our organization is we have a Kafka topics sitting in front of Logstash. So any client that wants to integrate with Elasticsearch, the only way they can integrate is with the Kafka. The clients can push asynchronously data into Kafka topics, and Logstash can take the messages from Kafka topics and uses Elasticsearch bulk API and ingest those data into Elasticsearch as a bulk loads. That's on the ingestion side. Then you have a Kibana side of the things that sits directly on top of the engine, and it gives you the user interface where you can query the data and you can build visualizations, you can build dashboards, you can there are DevOps tools. You can query data within Elasticsearch if you're developers. It's a really great platform. It's written in Angular. All of this is integrated as one stack. They call that now as Elastic Stack. So if you have any question on this, I would like to take a minute or so to answer that if anyone has any questions, or raise a hand. Why can't I?
Yeah, we haven't got anything yet, Jagadish, on the chat.
Okay, I'm not able to go to the next screen. I don't know why. Let me see if I can reduce this. And I think full screen is not, I think it's not allowing me to go to the next screen, next window. Because of the Mac, I have never used Zoom for sharing on a PowerPoint. Okay. Okay, can you see now? Yeah, I think I have to go with this. Okay, I cannot go to the full screen. I'm sorry about it, guys. So yeah, Elasticsearch is the distributed and scales horizontally, whether it's a 1 node cluster or a 10 node cluster or a 100 node cluster. You just can grow as your data grows. That's the beauty of it. So there are different flavors of Elasticsearch. One is a basic one that has an inbuilt basic security where the users and the groups that are associated with Elasticsearch are local users and local groups. That is a free version they call us. And there is an advanced gold and premium where if you want to do integration with your existing assets like Active Directory, LDAP, or you want to do OpenID integration or a SAML based integration, you need to have advanced security, you need to take with a premium license. On top of it, if you have to do with machine learning and SIM and APM, I think they are evolving in that space to a larger extent. You need to have a premium license. I think if your organization is just ingesting data and you don't have restrictions on giving access to the users, and you are capable of handling everything for small teams, maybe 10, 15, you can use with local users. But if you want to achieve for regulatory industries where you want to do like a document or field level security, it's not available in the basic license. You have to purchase from the vendor the advanced license. So in our organization, we have both, all our development and sandboxes are in basic license, but some production is in advanced, so platinum license, so that we get the best buck of it. So with respect to hiring resources, very difficult to get a good Elasticsearch experts in this space because the technology is so big, it's wide open. That is one of the challenges we found, but we groomed our people and who are solid developers. Now they have become experts in this platform. It's going to take 1.5 year time. You need to be prepared to take that time and groom your people to be effective in Elasticsearch. But if you start hiring resources, some of these resources are very expensive. You may want to get expensive resources, but to build and design this platform, but you need to build the talent in-house. If you don't build talent in-house, your budget will keep growing. And another thing I want to show it to you guys is this one Elasticsearch can be used by any language, because at the end of the day, all Elasticsearch exposes, whether it is an ingestion of the data or reading the data, is through REST APIs. Even Logstash, when it integrates with Elasticsearch, or Beats when it integrates with Elasticsearch, it calls their REST APIs. So this is a great platform. It's a platform agnostic, whether you are in Java, .NET, PHP, it doesn't matter which language the client application is written. You can all call Elasticsearch with the REST APIs. I think that is one of the ground rules that they have designed from day one, keeping in mind all these data. Even Kibana that is sitting on Elasticsearch is querying the data using REST APIs. One of the things that I want to share with you, this, if you understand this, you are understanding the search engine in general, whether you are doing Elasticsearch, whether you are doing Lucene, whether you are doing Solar, or a matter of fact, even for Google search engine, is based on these two principles. When you query the data, how accurate is this data is. You want to get a precise data, exact data. You want to go with high precision, but it is inversely proportional to recall. If you want to get high recall, that sometimes you may want to get a wide net of data. So when you do search on your Amazon store, sometimes you need to get the exact precisions. Sometimes you want to get a wide net. That means wide range of different selections when you're doing a search, so that you can do better research. Both are important. For example, I'll give you one example, why precision. Sometimes you think that exactly if I get precise data, I'm golden. That is not true. I'll tell you an analogy. Assume that someone wrote an effective algorithm, to find terrorists that are entering into the airports within the United States. Before 9/11, what happened was 99% of the time, if you look at the precision, is you can say that my precision is 99.999%. But still, there is that 0.001% that you may allow a terrorist into an airport, allow him to take a flight. If you turn that guy into a false positive, that means that guy is a terrorist, but you determine in your screening check that he's not a terrorist. even that one person can destroy the whole ecosystem. So sometimes it's really important to have high precision. Sometimes it's very important to have high recall. So the second use case is self-driving cars. Okay, what is the likelihood that I need to have high recall than precision for self-driving cars? Why? Because I don't want to accidentally, because I increase my precision, I may accidentally hit a pedestrian thinking that it is not a pedestrian, okay? It's a free lane where I can move the car. So that for that, I don't want to fall into any, any false positives. So it's actually a positive, but it is turning that as a negative to you, and you ride on the road and you hit a pedestrian. So both recall and precision are fundamental key artifacts for any search algorithm to work very efficiently. Elasticsearch is no different. Sometimes you want to get high precision, sometimes you get low precision and high recall. Both are important, but it all depends upon the use case that you are dealing with. So one of the things that is very interesting with Elasticsearch is fuzziness. Generally, this is one of the differentiator between relational databases and the search engines is you mistype your characters. It should be able to still find the right word. Assume that in this use case, you are typing for sharp, but actually the data is shard. The search engine can, because the fuzziness you enabled on that query as 1, it should be able to see if there are any words, any characters, okay, that has a distance of 1 that I can bring the relevant documents. In this case, the search engine is able to find sharp. If you look at the second one with fuzziness as 2, look at this. The allocation was completely misspelled with two characters wrong, but the algorithm is able to find it. But this is going to have a big performance hit, but sometimes you need this. Doing this in relational databases when you do predicate searches is going to be very tough. But this can be done with Elasticsearch with just one line in your query pattern. So that is something that Elasticsearch is really, really good and excels there. And also, so when you are querying large data sets, so the bool query in Elasticsearch is very, very interesting query. If you look at this, this is like query boosting without impacting your relevance. You are getting your results as a top hits based on your condition. For example, if I have a should condition, it won't impact the number of results it's going to bring from the search engine, but it affects the score. If I say should match last name equal to Frank, last name equal to Frank. So it will bring the same records, even if you don't have should, but the records that has Frank as a last name will be elevated to the top. I think that is one of the great characteristics to improve relevance within Elasticsearch is to have these little bit of knobs. Suppose you want to filter out data, okay, you can easily filter out within, you have a predicate that is, okay, for query in the data with must, and you can filter the data. So what happens in the engine, first it filters all the data within the engine, then it will try to match the predicate and give you the data. I think this is when you're writing complex searches and aggregations, the bool query is very, very important within the engine. So when you say here on the first statement, the clause is what kind of, how you're querying the search engine, affect the number of hits. That means whether that has an impact on the output of the results. If it is yes, that means it is going to have impact on the results. How many records is going to bring you back? Effects on score. That is that means it will not. If you have must, it will impact the number of records that are coming back, and also it will impact the score. But if you do must not, it only impact the number of records that doesn't match the criteria, but it won't affect any score. But on the otherwise, the vice versa is should, it won't have any impact on the hits, but it will affect the score. That is how you increase your precision by using should. So this is one complex thing that I think people will struggle when you are writing Boolean queries. I think even I struggled initially, but after taking that course and writing that exam, I think now I'm pretty much confident on how exactly these queries needs to be written. So the next big thing in Elasticsearch, if you look at Kavana, is the aggregations, your metric aggregations. That means what is my count, total count of records that I got on a given day. Okay, how many 400 errors I got, how many 500 errors I got. So those are all high-level metrics that you can capture in the dashboard. They are bucket aggregations, histogram, range, and terms aggregations. I'll give some of the examples if possible. So the bucket aggregation is grouping the buckets. So you assume that you get, you have some HTTP requests in your log system. You want to bucket them with how many requests are positive. That means 200 okay, how many requests are failed, how many requests are 401 denied requests. So you can get through bucket aggregation. Histogram is your graphs, your pie charts and all this. The range, times, the time zones. I want the data between this time and this time. The terms aggregation is dynamically grouping buckets. So these are some of the very interesting aggregations that you can see within Elasticsearch. So you may want to master these aggregations if you want to design your search engine very effectively. So so you can combine these aggregations also. Some of the examples is, how many, some of the bytes, how many bytes I got. What is the, served daily and the median response time? What is my average response time? Give me my top 5 countries with respect to the number of requests. What are the 2 most unexpected countries with respect to the number of requests per week? So these are, when you combine these aggregations, you can get these answers to these powerful questions. Think about these writing in relational databases. It's going to be quite challenging. So this is just as easy as it is with Elasticsearch. But one thing I forgot to tell you is Elasticsearch is never a source of record. Don't treat Elasticsearch as your source of record because it's an eventual consistent system like your Facebook. It's a time series database. It is like your Facebook or a Twitter where you stream the data continuously into the ecosystem. But you should always have a source system that is triggering these events. Don't make Elasticsearch as your primary source of truth. What if the engine becomes down? So you cannot use this like a replacement to your relational database. It is purely for your analytics, your operational reporting, your searches for your enterprises. It's always sitting after your OLTP process, your relational process. So keep that in mind when you're designing systems. One of the things that people can be misled is making Elasticsearch as the source of truth. That can be quite challenging if you don't observe that in the design phase. So common poor search performance. So I pick this just to make sure. If you look at this, if you have, any one of you have worked on Elasticsearch, what is happening is, suppose you want to search on blogs that mention ELK between 2016 and 2018. Okay, what I can do is I can do a Boolean query with a must match content into ELK and range of zoom. Okay, this looks like a straightforward query, but okay, it's going to have more impact on the engine itself. So the effective way to write this query is, look at this, okay? There is a filter clause and a must clause. What happens is in the filter, so before it matches for the keyword ELK, so it's going to look at all the documents and publish and look for the published date between 2016 and 18. Once the documents are filtered, then it is going to do a match. In the previous query, if you look at this, oops. I don't know what happened. Sorry, guys. So if you look at this query, what is happening, the engine is doing is, first it is filtering the data inside the engine, okay, between 2016 and 18, then it is doing a match class, versus it is doing all of these documents is doing, first it is doing a match, then it is checking, okay, whether this document belongs to 2016, between 2016 and 18. What if I have a document that is 2014? It is doing an unnecessary match. Here, it is actually doing a filter. So to eliminate, to get only the 2 years worth of data, assume that I have 15 years worth of blog data inside my search engine. So this query can become really, really big in terms of the performance. On top of it, all the filter clauses, Elasticsearch has caching inside the nodes, that is a query cache, node cache. It can cache all the data, so the subsequent calls, oh my God, what's happening? Somehow, I'm not able to. I'm not able to go to the next screen, but I'll keep like this for the time being. I don't know why. I'm not able to make a full screen. Sorry, guys. So I think the essence I was trying to tell is use filters whenever possible, because there is a query caching and node caching that happens in Elasticsearch. So when someone queries for the same data, okay, between 2016 and 2018 with a different match, but okay, all that is in the cache. It doesn't need to know, go to the disk and get the data. Okay, and aggregations are very powerful, but they can consume a great deal of memory. Aggregating too many documents, whenever possible, limit the number of documents in okay, that can aggregate. Let's look at a few examples on how to do this. Sorry, guys. Limit the scope of the query. Look at this. If I look at this, so what I'm doing is I have a large, okay, this is, assume that this is 1 billion documents or 1 million documents. I'm doing a filter on this. I'm getting, okay, giving, okay, runtime milliseconds that is less than 200 milliseconds. That means give me all, I'm interested in only the queries, okay, that are less than 200 milliseconds. And give me it in 2 buckets. Okay, less than 100, 0 to 100 in 1 bucket and 100 to 200 in 1 bucket. So since I use this filter clause with less than 200 milliseconds, so my query is going to be performing better. If I don't give this filter clause and just do the aggregations, because it has to go to each and every record and look if that query time, the runtime milliseconds is less than 200 milliseconds. So you always provide that the filter so that you can eliminate all unwanted queries in the first phase. Then you do the aggregation on that. So that will become very easy. Yeah, so that's it. I want to talk about in this session. Now I'm open to take questions, what your use cases are, what your experiences are, so that I should be able to answer the questions. So the floor is wide open. Maybe Pete, you may want to open for the conversation if you want.
Yeah, sure. Sure. I mean, yeah, I definitely encourage questions, specifically around anything that you saw with any of this, kind of dig deep into this. I mean, obviously, like Jagdish was mentioning, this certification is not the easiest. There are very few. I think there's only really, I want to say, Jagdish, maybe 2 within your entire organization that have it.
Yeah.
You being one of them. So, I mean, I guess we could talk a little bit about that, because you mentioned earlier on the call that, you know, you encourage people to, well, I guess I'm going to back up a little bit. What really got you interested in Elastic? I mean, obviously there are competitors to Elastic. What was the first kind of driving factor for you that really interested you?
Yeah, one is the open source model for Elasticsearch is the great interest. I've looked at the latest migration of eBay when they moved away from their old search engine to Elasticsearch. Their technical implementation, they wrote a couple of blogs, how they've implemented Elasticsearch on many billions. I think they serve about 35 billion requests on Elasticsearch. The search that you do today in eBay is all driven underlying with the Elasticsearch. So that was my appealing. That is where I got attracted into the Elasticsearch. On top of it, as I said, the biggest success for any enterprise, for any product, we spend more time on integration. Elasticsearch made the integration damn easy with many of these connectors that comes with Logstash. I think the newer versions of Elasticsearch, they now talk about pipelines and painless scripting. You can have ingest nodes inside Elasticsearch. If you want to assume that you put some data and you want to clean the data within Elasticsearch, you can do with painless. The integration and the user interface along with the search engine together make a compelling argument for any enterprise to build search engines on Elastic, because you don't need to reinvent your user interface platform. You don't need to spend time and money on your integration. You name the database and you name the integration technology. It has hundreds of integrations or connectors available. So that was one of my appealing things. The first thing is the eBay thing, and the second one is the integration with Elasticsearch made damn easy along with the user interface.
What has been the size of the organization, right? I mean, we talked a little bit about you being in an enterprise shop, you know, with, let's say, 8,000 and 10,000 employees. What do you think has been the biggest challenge to take something like Elasticsearch and roll it out enterprise-wide?
Oh, it's the skill set is a challenge, really. It's hard to find skill set that understand the operating system. By the way, this is all running on Linux. Understanding the operating system, the storage, the way how you design the storage, on top of it, how you architect the system, on top of it, how you secure this system, how do you make your regulatory requirements saying that only this set of the users should be able to look at this set of documents. I think it's quite challenging to understand different realms of security, different realms of infrastructure, different realms of the application development. The challenge is the skill set. Even now, I can see people who tries Elasticsearch. They think that it is very great when they go on their laptop, but when it comes to complex integration, dealing with complex stuff, on building large scale clusters, they don't have knowledge to manage the platform. So it's going to take some time, Pete. I think it's a 1 to 1.5 year. If you are the leader of your search engine, you need to identify the talent around it. People who has an appetite to have strong development background, strong ability to understand infrastructure. I didn't talk about it, and we automate the whole Elasticsearch. We have about 8 to 10 clusters. We automate all the Elasticsearch clusters with Ansible. So with one keystroke, we can build the whole cluster. That is something that we put a lot of effort in learning the complete automation and configuration management. Our Ansible playbooks, along with the roles for building Elasticsearch, along with Logstash, Kibana, Beats, and all, is more than 10,000 lines of code. It's like we manage that like a development project. So that is one of the things, managing this cluster and using the right configuration tools, because we are a heavy Red Hat shop. So Ansible is the one that we have picked to automate that. That is, I think, that is something that you need to take care from day one. Otherwise, you cannot manage the clusters as they grow big. You need to have automation in place. Whether it's a rolling upgrade, whether you're doing an update of a patches, whether you are downgrading or you are starting and stopping clusters, everything needs to be automated. You should have very less human touch points going and touching these clusters. You have to automate all of this.
What interested you most about Ansible over other products?
Ansible, one of the things that Ansible is appealing to us is, if you look at Puppet and Chef or other automation tools that are available in the industry, and they are very successful implementations, but they are all agent driven. All the client machines that are using Chef or Puppet, they have to use agents. Whereas with Ansible, it's an SSH communication. I don't need to have any software on the machine where I'm running an Ansible play. For example, if I'm installing an Elasticsearch engine, I don't need to have anything on the Elasticsearch node itself other than a Python runtime, because it's all SSH access that I do from a remote machine to the Elasticsearch node and run those plays. Those plays will be converted that into an equivalent Unix commands or Linux commands. So that is one of the, it's an agentless system that makes Ansible more appealing. But what I don't like about Ansible is the state management. Assume that in the middle of your play, if something goes wrong, if you have to replay that, you have to replay the whole play again. It doesn't do like Terraform. If you have worked on Terraform, it does manage this, maintain the state. It knows when you run the Terraform again, it knows where it has failed last time, and it knows to start from that instance. But that is one challenging thing with Ansible. The state management is quite sometimes irritating, but you have to see the advantages that it gives. It is better than nothing. It's far better than nothing. So it's working really well, but we have built a lot of expertise around it.
No, that's fantastic. Well, does anybody else have any other questions before we kind of wrap up, or specifically around some of the slides, things that Jagadish covered today?
Yeah, ask the general questions also. I'm free to answer. Okay, even if it's a general question.
Hey, Jagdish, Kalyan here. How are you?
Yes, Kalyan. Hey.
So I have a question. So you talked about using Elasticsearch as source of truth, right? Yes, I do agree. But I would like to know more reasons, like, and also the use cases where we can use from application perspective. Say, for example, what I'm understanding is if I am not using Elastic as source of truth, so if Elastic cluster is down for any reason, my core business function should not stop. Is that the correct thing?
It's not that way. Yes. If Elasticsearch is down, See, there are OLTP systems where the source of truth it is guaranteed. If you look at a database system as a whole, you write the records into databases as a transactions. That means you complete a transaction, or you roll back, or you error out while writing into a transaction. Elasticsearch is not like that. Elasticsearch is writing records eventually. That means some of the records may override with each other. You may not see always the consistent data. Consistent data means the accurate, 100% accurate. There are always 1 to 2% of accuracy mismatch between your source system and the Elasticsearch engine. That is one of the reasons why they say that you cannot treat that like an RDBMS system. When it comes to availability, yes, it needs to be built as a tier 1 system. Okay, there's nothing that is going to stop you by building Elasticsearch as a tier 1 system, but it is not a transactional system like your SQL Server or your Oracle or DB2, where you have, once a transaction is committed, it is guaranteed that no one can change the state of the transaction. But in Elasticsearch, you can get 2 records where a second record can override the first record if you don't take care of consistency properly. So there are always challenges you get, whether you want to get high throughput or you got high accuracy. So you have to compromise on that. That is one of the reasons why they say that, okay, it cannot be a source of truth. Not because of this availability.
Okay. Yeah. Thanks, Jagdish.
Hi, this is Bhavani. I had a question.
Hi,
I'm curious, how would you go about some performance monitoring? Say, for example, you have a long-running query hitting the cluster. How would you track the source of the query, and how would you monitor performance?
Yeah, great question. I think actually we are running into that right now. Okay, if the query is coming from Kibana, okay, most probably the query is optimized by the Elasticsearch team itself. If someone is writing a query outside and making a REST API calls and you find the query, there is something called slow queries. You can enable that and it will generate something called slowquery.log, if I remember the exact file name. So that is how you can identify the slow queries. So once you identify the slow queries, it's about looking at the data. Sometimes, okay, it is just the query needs to be changed, or sometimes your data model is wrong. Your search pattern, the way how you are searching the data is different with the way how you ingested the data. You may have to really tweak your data model. Whether you are doing with, whether it could be mappings that you may have to change, or you may want to do better denormalization. Maybe the queries, predicates that you are using, they are not effectively mapped, or if you're doing aggregation, if that query is, you're not doing a keyword search, that means, okay, you can have a big performance hit. At the end of the day, there's not a good answer. First of all, you look at the query and look at the data model, look at the mapping and enable slow logs and combine this. Okay, that is where your experience comes. That is where ability to see how do you write best performance queries. You avoid the pitfalls, some of the things that I said in the presentation, like how do you use filters at the right time? How do you use the aggregations with the right keywords? And things like that needs to be looked. It's not a good short answer, but it's a holistic thing. First, I would say that you need to find what that slow query is. Look at that query. Immediately, the next thing I'll do is the mapping, how that query is mapped, and look at the search pattern predicate and see if you can improve on that. Does that answer?
Yeah, that does answer my question. I had one more question related though. So are you able to set a timeout for your query? So it's like you let the query run for about 30 seconds and then kill it after that if it's kind of not still ending. Are you able to terminate?
Yeah, I think there is a timeout that is defined in Kavana by default. The query will time out after 60 seconds. At the end of the day, it is, how are you reading this data? Are you reading from Kavana? Or are you reading from REST APIs?
I try to hit using a REST API. So I do have a timeout parameter in my query, but I think it's not effective. The query, I set a timeout for 30 seconds. The query still runs after that.
Yeah, I think what you have to do is, it's a HTTP REST client. You need to set a HTTP timeout than the query timeout. Okay, query timeout may not be. So what happens when you do a HTTP timeout, the client, the socket connection is terminated. The client is going to send a reset packet signal to the server saying that I no longer need this TCP connection, and it is going to get terminated. You may want to set up at the HTTP level, HTTP connection level, then the timeout, then the query timeout level.
So is there anything available at the cluster level? So, I mean, just for the health of the cluster, you terminate any long running query at a particular time, or you let it run like that?
I didn't see that setting anywhere in the docs, but I'll take this as an action item. If I find something, I'm going to send this mail to Pete. And that's an interesting thing. If I can set up at a cluster level, any query that executes more than X number of seconds automatically, terminate that query. I'll find out and I'll let you know. I'll make a note of this.
Yeah, thank you. That's all I had.
Thank you. Good question. Yeah, we have a few more minutes. I'm open to take a couple of questions. Yeah, even if it is not relevant, and if you're designing brand new, you can ask any questions that, where are you with what would be your interest? Why are you, you can ask anything related to Elasticsearch. I should be able to answer.
It looks like we might not have any more, Jagadish, for us today, but again, this session will be recorded. It will be put up on our YouTube channel as well as our website, as always. And then if you want, Jagadish, definitely reach back out to me and send me once you research that question, then I can get that out. And then also, if you want me to share the slide deck, you can send that to me as well, and I can put that up.
Yeah, sure. Yeah.
All right.
Someone is asking, what is your YouTube channel?
It's the IR Talent YouTube channel. You can actually even go, Roxanne, you can go to irtalent.com, and on the top right hand, on the bar, you'll see sessions. If you click that, then you can see all of the sessions that we've already loaded up. It'll take us a few days to load this one up because we actually have to edit it, but we'll get it out there. All right, well, thanks again, everybody, for joining another one. The next week will be next Wednesday at 1 p.m. as usual, and that will be one on cybersecurity and actually securing your code base. Speaker actually outside of Austin, Texas. So pretty excited about that one. And then we'll take a week off, and then we'll come back in July. So thanks again, Jagadish. Thank you so much. Really appreciate it. Hopefully we'll get out for coffee and lunch soon when things start to open up a little bit.
Okay.
And thank you, everybody, for joining, and see you guys next week.
Thank you.
All right. Thank you.